Hello viewers, welcome back to class. I'm super excited to have you guys back to class. Alright, now in this class we're going to be examining problems and solutions under indices. Alright, in the first lesson we looked at the laws of indices and indices in general. Now in this video we're going to be looking at problems and solutions. So we're going to be solving problems using the laws of indices. So guys, if you are new in this channel, do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell. More exciting videos, and don't forget to like this video, share this video, and make your necessary comment. Please, one of our policy, you must not skip any part of this video. Avoid every unnecessary distraction and ensure that you replay the video over and over again till you understand what we teach here. Alright, so let's get started. On the board, we still have this section to contain all the laws of indices that we explained in the previous video. Now we have problems and solutions on this page. Question number 1, we are asked to simplify the following. So the first is question 1, 2, 3, 4, 5. Roman figure 1 to Roman figure 5. Under question number 1. Right? Now, this is our solution. We already have the problems. Now we provide our solution. So when we start with Roman figure 1, which is 10 raised to power 5 multiplied by 10 raised to power 4. Now, this is an index having a power, multiply an index having what? A power. Index notation. And now, you understand that when one index multiplies another, all you do is to check out whether they have equal base. Of course, you should know what base is. By now, we have this A as power, y this is the base, alright? So you should be able to know whether the base have equal values. This is the ground to which you can pick one of the base, then add, subtract, or do anything with the powers. So first is to ascertain whether we have equal base. Of course we have 10 as the base. So you pick one of the base, then followed by the first power. Now, what connects these two bases is multiplication. And we said that in indices, multiplication turns to what? Addition. So that means we are going to add the powers. Then finally, from here, we are going to have 10 raised to power what? 9. This is our answer. It's as simple as this. We'll try our possible best to leave our answer in index form also. But should the case you are dealing with objective for OBJ students and you find out that the option, one of the options is in index form, then you know what to do by simply multiply 10 in numbers of its power. So if 10 is raised to the power of 9, that means we have this to be what? 10 multiply itself 9 consecutive times. Are you there? Yeah. Now we move to Roman figure 2. And in Roman figure 2, we were given y raised to power 3 multiplied by y raised to power 9. So with what we have here, the first thing you always check out for when you have the product or the multiplication of two base to different or equal powers, the first thing you do is to check whether the base are equal. Of course, the base here is y, and the other base also is y. So you put down the base, one of the equal base, then go with the first power, which is 3. Now, what connects the second base to the first base is multiplication. That means I need to add their powers. And automatically, this will have given us y raised to the power of 12. For this, you cannot simplify this further, but for the first case, you can simplify further. Right? And you know that 10 raised to the power 9 is what in figure, maybe in money. Alright? Okay, 10 raised to the power 9 is 1 billion. Right? Yeah, this is 1 billion we just have here. 1 billion. 1 million is 10 raised to the power 6, right? Okay, now we have Roman figure 3. And in Roman figure 3, we have m raised to the power 6 divided by what? M raised to the power of 4. And don't forget also that we have one index notation being multiplied by another. Now, when this happens, what do? We first of all check out whether they have equal base. Of course they do. Then I will put down the base. Now the next thing I quickly do is to go with the first power, put down the first power, Now what connects the second base to the first base is what? Division. And division turns towards subtraction in indices. That is to say we have to subtract their powers. Then when we remove 4 from 6, the power remains 2. This is the answer to this very question. Now also, we have Roman figure 4 on the board. What? 2 raised to the power 5 divided by 2. And in indices, we understand that anytime we have a number without a power, it shows that the power is 1. If it is any other power, it must be stated. Even though it's 0, it should be stated. Negative, it should be stated. Positive, 2 and above. But when a number is given without the power of that number is 1. So therefore, we can rewrite this question and have this to be what? 2 raised to the power 5, 2 raised to the power 1. Now, in this case, we see that these two bases are equal. So you pick one of these base, then go with the first power, which is 5. And you know that in indices, division turns toward minus. And automatically, this will have given us what? 2 raised to the power 4. Now, this is your answer. But for objective students, if their answer is not in index notation, this shows that this is 2 multiplied by 2 multiplied by 2 in 4 places, which will have given us 16. Alright? So 2 times 2 is 4, times 2 is 8, and 8 times 2 is 16. That's how we had it. But you can stop here if you are dealing with just pen and paper exam. Alright? Then, Roman figure 5, we were given that 5 raised to the power 3 multiplied by 5 raised to the power 4, then divided by 5 raised to the power 5. When we look at this question number 5, we see that it is a combination of the first two laws of indices. Of course, you can see it here on the board. Multiplication and division all in one. So you are multiplying the first index notation by the second, and you are dividing the second by the third. Are you there? Yes. So what do? All I need to do is to first check out if they all have equal base. Of course they do. All I just need to do is to pick one of the base. Now go with the first power, which is 3. Now what connects the second base to the first base is multiplication, and therefore we are going to add the powers. We have plus 4. Now what connects the third base to the second base? Division, and division is negative. So you have minus 5. Therefore you can have this as 5. You can decide to first of all go with the addition. 3 plus 4 would have given us 7. Then minus 5. And 7 minus 5 will give us 2. Now I can decide to leave my answer here or further my answer based on objective condition. And 5 raised to the power 2 means 5 multiplied by 5. Just 5 in 2 times. So I can decide to stop it. So this is the first session of question number 1. So alright, now we have question number 2 on the board, and we are asked to simplify the following. Don't forget we have the column for our logs. They are all here. Okay, now the first question we are asked to simplify is 4 raised to the power minus 3. Of course, these are simple questions, but now this is solution to the problems we have on the board. Roman figure 1, we have 4 raised to the power minus 3. So guys, all I need to do here is to identify which type of law can this be traced to. Among the 7 laws of the indices, does this question look like any of the laws stated? Of course, yes. This is negative power law. So if I come to law number 4, I'll see it here that if I have something like this, the first thing I do is to remove the negative power. Are you there? So all I just need to do now is to turn the minus 1, the minus as 1 over. Then repeat the base and the power. So for this now, I'm going to have this as 1 over 4 multiplied by 4 multiplied by another 4. And 4 times 4 is 16. 16 times 4 is 64. So I have 1 over 64. This is the answer to this question. Then Roman figure 2. We are given 7 raised to the power of 0. Guys, you don't need to solve this. You don't need to kill yourself about this. Anything raised to the power of 0 is 1. We will validate this. in one of our videos, alright? So anything raised to the power of 1, 0 is 1, so you don't need to think about this. The Roman figure 3, we have 3x raised to the power minus 3. Guys, you need to examine this question very well. Is minus 3 affecting both 3x? Of course, 3 is a base, s is base, that means 3s is a base, while minus 3 is the power. Now, the first thing you need to do is, does this minus 3 affect 3? Of course not. It only affects x, because if you want to pronounce this now, this is 3x raised to power of minus 3, not all raised to power minus 3. Is that correct? So this is the difference between this question 3 and question 5. This and this, they are not the same. So for this now, this power only affects x. And then I can have this as 3 times x raised to power minus 3. Then I will now work on this. And based on what we have here, negative power can be reduced to what? 3 times 1 over x raised to power 3. All we just need to do now is 3 in its fraction form is over 1. So we multiply out the numerator and as well multiply out the denominators. So 3 multiplied by 1 would have given us 3, which is the numerator, and 1 multiplied by s cubed, we have this as what? S cubed. It's as simple as this. Then we move to the next page of the board, and we have question number 4 on the board. Question number 4, we have x raised to the power 3 divided by s raised to the power minus 3. Now, we see that this question we have here is a combination of 2 laws. First is the second law, second is the fourth law. Is that so? Between these are 2 bases that are connected with division. First law, second law obeys. Then the last base has a negative power. Fourth law obeys. Which one should I go for? According to the laws, division came before the law of negative power. Is that correct? So we are going to start with division. Of course, anyone you use, you are going to have the same result, because in mathematics, there is no one way to solving one problem. Every mathematical question can be solved numbers of ways. Are you there? Yes, they can be solved numbers of ways. But we want to solve it this way. We want to follow the laws that we have here. So we will pick one of these, since the bases are equal. Pull down 3. Now, what connects this first base to the second base is division. And in indices, division turns to subtraction. Then followed by the next power. And the next power is minus 3. So we are going to use bracket since we have minus minus. Now, at this point, I will directly open the bracket by minus. So put that 3. Minus times minus, we have plus 3. And this would have given us as 3 plus 3. This is 6. Then finally, we come to the question number what? Roman figure 5. And this happens to be what? 3x minus 3. So with what we have here now, we have a combination. Listen carefully. We have a combination of fourth law and fifth law. Negative power and product power law. Are we there? So this comes first. So we are going to first of all remove the negative. Understand that this power affects everything inside the bracket. So the first thing we are going to make use of now is law 4 before law 5. Then this will have given us, this negative will become 1 all over the base to the positive power. Now at this point we cannot leave our answer here because the 2 numbers inside the bracket are affected with that power using this fifth law. So if this is 3 and this is x, both 3 and x will be affected by that power 3. This is indirectly as 1 over 3 raised to power 3 multiplied by s raised to power 3. This 3 affects this because we said power outside the bracket can multiply the powers inside the bracket. And of course, this 3 here initially have power of 1. X here have the power of 1. Then when we multiply out, we have 3 times 3 times 3. Don't forget that 3 raised to power 3 means 3 multiply each set 3 times. And that would have given us 27. 3 times 3 is 9. And 9 times 3 is 27. 1 all over 27, and s raised to the power 3 cannot be simplified further. We will stop this at this point. So this is the answer to this very question we have on the board. So we are quickly going to solve question number 3 without wasting much of our time. Okay guys, now we have question number 3 on the board, and we are asked to simplify question Roman figure 1 to Roman figure 5 also. So we put down our solution. First, we have Roman figure 1, which is 5y multiplied by what? 4y raised to the power 5. Now, when we look at this now, comparing this to any of these laws that we have here, we will discover that the laws that we stated here did not have coefficients. Are we there? But if this is my y now, y has a coefficient here, and this other y have coefficient, and they are being multiplied. Are we there? All I need to do first is to separate the numbers from the letters, because this is alphanumeric terms. Are you there? Separate the numbers from the letters. Of course, you know that 5y is the same thing as 5 times y. Similarly, 4y raised to the power 5 is the same thing as what? 4 times y raised to the power 5. So therefore, we can have this to be what? 5 times y multiplied by 4 times y raised to the power 5, because they are big base. They are not the same. So we need to split it and separate in such a way that they can be the same. Are we there? Now we are doing this because we want to obey the laws of indices. We can multiply this out in one line and get the answer. For objective students, we are going to do that. But if this question is given to you for as an answer booklet, so if this question is given to you and you are required to work this out, please don't follow the shortcut. This should be the best process to follow. So in this case now, I will separate the numbers from the letters. So this will give me 5 multiplied by 4 multiplied by y raised to the power 5. And understand that in indices, any base without a power has a power of 1. So this is y raised to the power 1. Now, if I multiply 4 by 5 or 5 by 4, this would have given us 20. Multiply by, I want to apply the first law of indices. So I will pick one of the base, y, this is y multiplied by y. Then pick the first power, which is 1. Multiplication turns to what? Addition. I have this. Then finally, this will have given us 20y raised to the power of what? 6. This is the answer, because 1 plus 5 is 6. We are done with Roman figure 1. Now, in a short while, to solve this as OBJ, without wasting much of your time, 1 second. This times this guy, just multiply the number out, that will give you 20. You know that this is 1, add 1 to 5, you have 6. You don't need to go through this for objectives. Are we there? So for OBJ students, either JAM, WAEC, or whichever form of OBJ that you're writing, you don't need to work it out this way. All you just need to do, number multiply number, put down the result, then pick one of the base, just add the powers directly, and you get your answer. Okay? Now we move down to this other guy, which is Roman figure 2. And we have this to be 24 x raised to the power 6 all over 8x raised to the power of 4. Now the first thing we will quickly do also is to separate the numbers from the letters. So we can have this as 24 over 8 multiplied by s raised to the power 6 over s raised to the power 4. Of course, earlier on I explained that in indices, if I have a over b, in mathematics, is same thing as what? A divided by b. That means the rules that work for this will also work for this. Hence, I can decide to have this as final answer 24 divided by 8 would have given us 3 multiplied by x raised to the power 6 minus 4. Because this first one is being divided by the second. So you can rewrite this as x raised to the power 6 divided by x raised to the power 4. But this is a waste of life, a waste of time. That's why I didn't do this. But you can also do it this way. Convert it to this form before you apply the theory. But understand that this in mathematics is equivalent to this. So what happens to this equally happens to this. Are we there? Let's go. So at this point now, if we remove 4 from 6, we will have it to be what? 2. So this becomes 3s raised to the power 2. This is the answer to question number 2. It's as simple as that. Then question number 3, we have Roman figure 3. And in this Roman figure 3, we have 9 multiplied by 10 raised to the power 9 all over 3 multiplied by 10 raised to the power 3. Of course now, 9 and 3, they are numbers without powers. And 10 and 10, they are numbers with powers. That means I can liken this question to be like this. All I need to do now is still to separate this from this guy and separate 10 over raised to the power 9 all over 10 raised to the power 3. What I mean is that we can have this to be what? 9 over 3 multiplied by what? 10 raised to the power 9 over 10 raised to the power 3. Numerator multiply numerator, we have this. Denominator multiply denominator, we have this. Why are we doing all of this? So that we can at least apply one of the laws of indices. We can solve this direct. Are you there? Yes, you can solve it direct. You can solve it direct. Okay. Now, all we need to do, 9 divided by 3 is 3. Multiplied by 10 raised to the power 9 minus 3, still making use of what? This same rule that we use here, which is law number 2, division. So we are dividing 10 raised to the power 9 by 10 raised to the power 3. That means I just need to remove 3 from 9. That's all. Alright? Then this finally becomes 3 times 10 raised to the power 6. Guys, this is what? 3 million. Should in case your answer is not in standard form. Alright? This is standard form. Should in case your answer is not in standard form for objective students, you can convert this to what? A simple number which will have given us 3 million. Alright. Now, Roman figure 4. We have 9 m raised to the power minus 5 multiplied by 4 m raised to the power 6. The same thing that we did when we solved Roman figure 1 is what we are still going to do there. We have a mixture of numbers and letters, which is alphabetical terms, right? All I need to do is to separate this. And I will have this to be what? 9 multiplied by m raised to the power minus 5. Then multiply by 4, then 4 multiplied by m raised to the power 6. Now I can multiply the numbers, which is this guy times this guy. Then multiply by m raised to the power minus 5. Multiply by what? M raised to the power 6. So we can apply the law of indices, first law of indices to the last two what? Index form, right? So while I multiply 9 by 4 and have 36, I'm going to take m. Now the base here is m. Pick one of the base, then add the powers using the law number 1. Because the two bases were connected with multiplication. Are you there? Yes, they are connected with multiplication. Now this would have given us 36. Now minus 5 plus 1, minus 5 plus 6 is plus 1. So that would have given us m raised to the power 1, which is m. So this is 36 m. Then finally we want to work on Roman figure 5. And this is Roman figure 5, which is 5x squared multiplied by 4x0, then multiplied by 2x raised to the power minus 6. So at this point, guys, all we simply do here is to what? Multiply out the numbers. Of course, this is 5 times s squared, and this is 4 times s raised to the power 0, and this is 2 times s raised to the power minus 6. So I can separate the numbers from the letters, which I will have this as 5 times 4 times 2. Let me just pick all the numbers, then multiply by s raised to the power 2, multiply by s raised to the power 0, multiply by s raised to the power what? Minus 6. So guys, at this point, all I just need to do is to multiply 5 by 4 to give me 20, and 20 by 2 to give us 40. Automatically, this will have given us 40. Now, when we look at all these last terms that we have here, we discover that they are all of equal base. I mean that base s all true. That means I can pick one base and connect the powers with the respective signs that we have here, and everything happens to be multiplication. So all I need to do is to multiply by x. I have 2 plus the middle power is 0, then plus or minus 6. Now this will be plus minus 6, and minus will take care of plus to give us minus. And at this point, guys, we are going to have this as 40. Now, 2 plus 0 is 2, and 2 minus 6 is minus 4. So this will have given us x raised to the power minus 4. And we cannot leave our answer like this. Don't forget, this is a question that you can be given. In fact, it was one of the questions we were given in question number 2. That we solved earlier. So you cannot leave your answer here having a negative power. it is not accepted. Don't forget, it is not accepted. So I need to remove this negative power. And for me to be able to remove this now, I need to understand that this power only affects x. Are we there? We are quickly going to use law 4, which is what? The negative power law. And when we use that law here, we are going to have this as 40 multiplied by what? 1 over s raised to power 4. And this is giving us 40 over s raised to power 4. So this is the answer to this very set of questions. So guys, you see, solving indices is something very, very interesting. It is always easy to solve indices problems when you know these 7 laws of indices. So you cannot solve indices problem, like I said earlier, without the use of these laws. So you must get mastery in solving problems of indices. Therefore, guys, you must acquaint yourself with these laws of indices. When you know these laws, you solve